We are back on this rather nice Quicksilver Pilothouse 625. Knew that. We're fitting this Minn Kota trolley motor to it. This is part 2, so we've already physically mounted the motor. We made a bit of stainless plate to stand it off a bit from the gunwale. We made a detachable section of handrail and we fitted the GPS transceiver, or heading sensor, Minn Kota call it. In this video, we're going to sort out power and charging. So some of you eagle-eyed people might have noticed that this is a 24 volt Minn Kota and all our onboard electrics are 12 volts. So we need to work out a power supply for the 24 volt and then we need to figure out how we're going to charge the 24 volt system. Got a good idea for that. I'll explain that later on. We also need to move the nav lights. They're down there on the bow right now, but you can't really see them. I don't think they actually comply right now with regulation. So we're going to move them from there up to the top of the wheelhouse here. And then the last thing we're going to do is test everything we've done, make sure it works. Anyway, all of that said, it's easy to stand here and talk about. So let's get on with it. As standard, these units are designed to bolt directly to the deck, but Minn Kota sell loads of options and extras so you can spec yours how you want it. This one came with a quick release bracket and quick release plug and socket. Because they work mostly wirelessly, the only thing we really need to run to the motor is power. The first thing I'm working on is fitting the plug to the motor. Since it's designed to be permanently fixed, it comes as standard with ring terminals to bolt directly onto a battery, but our power supply is elsewhere, so I'm going to cut the ring terminals off and hook up the plug. I'm just using crimp terminals to make the joint, and then it'll get 2 layers of heat shrink to insulate and seal it, and going over both wires and the joint is a length of braided or woven cable sleeve. The wiring itself on the unit is pretty robust and good quality, but the sleeve will give a bit of extra protection, and it looks a lot nicer than red and black. On top of that, as far as cable protection goes, it's really flexible, which we need. This is the factory supplied quick dismount base. Comes in 2 parts. We have one big plastic rectangle here that bolts to the Minn Kota itself, made of HDPE, and we have a little plastic rectangle that bolts to the deck, or in our case the deck and the stainless plate. It's really simple. To mount and dismount the unit, all you do is land that little rectangle inside the big rectangle. We've got a wee horseshoe pin here. Slide that all the way through. And that's the motor mounted. The only thing left to do is put a wee R-clip on the outside of the pin to stop it sliding out. Naturally, when you have a plug, you have a socket. So I'm fitting that in the anchor locker. The other end of the socket runs to the battery. So we've had to extend the power cable about 15 feet or 4.5 meters depending where you live. And because of the length of run, we're using 8 gauge wire or 10 millimeters squared. The length of run dictates the weight of the cable that we're using, but most importantly, we're using marine grade wire, which is tinned copper and has much better corrosion resistance than plain copper. This is the motor side of the power cable that I've just been talking about. We have our quick connect tail fitted and we've ran it into some braided sheathing. Give it a bit of extra protection, make it look a little bit nicer. The socket for this plug is in the anchor locker, mounted here. That is connected to the batteries. So all we need to do is take our quick connect plug, take the cap off there, and pop that in. It's locked. We can use our rope well here in the anchor locker to keep it nice and secure and out of the way, and then we can enjoy life. Disconnecting it is just as easy. You just twist this, pull that. Also make sure you put the cover back on the plug so that you don't have someone like me trying to find faults in a few years' time and moaning about corroded pins. The extended cable runs from the back of that socket and into the locker under the main deck. This locker is a pretty good place for something heavy like a battery. It's midships and low down, so it's good for balance. Case in point, the 12 volt battery was already installed here, so it's a perfect place to add another battery. We did have to extend the shelf to fit both batteries there, since the 24 volt unit is a bit of a brute. In terms of wiring, it's pretty simple. The 12 volt battery was already there but running port to starboard. We've now rotated it 90 degrees to make plenty of room, but the wiring doesn't change there, we just had to move it a little bit. Hooking up the feed for the motor is also fairly simple. We're just going to put it onto the pins off the 24 volt battery with some ring terminals. It's more or less a straight run from there, with the exception of a 60 amp circuit breaker on the positive wire. Now, I've mentioned a few times that the motor we just installed is 24 volts, and so far I've kind of glossed over the topic. I've also mentioned that our onboard electrics are 12 volts, which is usually the case with leisure boats and small commercials. So, what kind of problems might we have to deal with when we stick a 24 volt system in alongside a 12 volt system? Sometimes that's a big problem. In our case, it's pretty much fine. On the one hand, on our 12 volts, we've got all our critical systems, like navigation, lights, and the power for the main engine. So it's kind of a good idea to keep the two systems separate, and that's more or less what we've done. On the other hand, on the 24 volt side, it's running a big motor with a peak draw of 60 amps, which at 24 volts is like 1400 watts. It's quite a lot. Even with a draw of 13 to 1400 watts, in theory the Minn Kota should be able to move the boat around, but it's by no means a get you home motor. So keeping the two systems independent is a good idea, because if the 24 volt system fails, it's inconvenient. If the 12 volt system was to discharge or fail, it's a potential disaster. Now, I've just said that we're installing the 12 and 24 volt supplies independently, but that's not strictly true. This is a battery to battery charger, 12 to 24 volts from Victron Energy. I chose it not only because it charges 12 to 24 volts, but it's also capable of charging lithium batteries, including LiFePO. That's absolutely something that you need to think about when you're buying a battery charger. Now, the other key features of this particular unit is it's configurable. So we can set this up so it's only ever using available headroom from the 12 volt, 24 volt side, and we can put the power limits on it as well. We can set this up to make sure it only charges when the engine is running, and even then, with the engine running, if the 12 volt side was to drop below, say, 12.5 volts, it'll turn off automatically, which in theory means that we should never be robbing power from our critical systems. It's going to go under the seat here, because there's lots of room and it's an easy run to where the batteries are installed. Joining the battery to battery charger under the seat is this 240 volt smart charger, also from Victron Energy. This is more or less just a trickle charger. It's a maximum of 16 amps, but the idea is the owner will be able to run a supply from his house or a shore power supply to make sure the 24 volt battery is always fully charged before he leaves. It gives him maximum runtime, and it reduces the charging demand on the 12 volt system. It means that instead of having to bulk charge from a low charge state, it's just trickling, keeping it topped up. Both of these are Victron. Other brands are available, but I've always had good experience with Victron, especially in the marine environment. Since we have a 240 charger, that means we need a 240 supply. We're fitting an IP44 socket on the main deck in the wheelhouse, and it's running directly into the seat where we're fitting the two charging units. You know the old saying about measure twice and cut once? In this case, we're measuring about 9 times and cutting once. Top tip, if you are marking on gel coat, a dry wipe marker is pretty useful. Pencil works too, but the handy thing of dry wipe is it wipes off. Failing that, you can just use masking tape. Once a hole is cut, we need to make sure our plug is going to sit nice and level. Using a spirit level on a boat is a waste of time because the chances of the boat itself being level are pretty slim. The best thing to do is measure off fixed points. Like in our case, we are measuring off the window and the deck. Once we're happy, we're going to make 4 pilot holes and stick some screws in. Naturally, we're using stainless steel screws, and yes, they're corrosion resistant, but they're also very brittle, so if you try and send a stainless screw without a pilot hole, it will snap and ruin your day. Quick look under the seat before we start, and it's really cramped in here, so I don't know how much footage we're going to get. Anyway, since a 240 feed is only there to power one thing, we're just going to fit a spur. Should the owner ever want to add other things on the 240 volt circuit, in this case there's not really any reason to, but if he does, he'll have to fit a proper distribution board here. Everything else in the 240 stuff is pretty standard, but we are going to swap out the 13 amp fuse in the spur for a 5 amp one, which is what our charger needs. Next, we're fitting the chargers. All of the cables going to and from the batteries and fitting into the chargers are just clamped in. And when you're dealing with cable clamps, the best thing to do is fit bootlace ferrules on the ends to keep them tidy and remove any risk of stray strands arcing between pins. I'm also going to use my cute pink label maker to label all the cables before I send them down into the locker. The last thing we need is to confuse one of them. I did try and record actually mounting these chargers inside the locker, but honestly I was mostly one-handed, so it was a real nightmare to try and get any sort of usable footage. But here's the finished product. We're fitting 2 for now bus bars down here to handle supply from both chargers, one 24 volt and one negative. The 24 volt power from both the battery to battery and 240 volt charger will run through the positive bus bar. Since one requires the engine to be running and the other requires shore power cable connected, it's not likely they'll both be supplying power at the same time. But just in case, you're going to fit a 50 amp mega fuse on the positive feed to the battery, since the battery itself can only accept a maximum of 50 amps. Speaking of the feed to the battery, we're putting positive and negative in through an Anderson plug. We could also hook up to the same pins as the supply to the motor, but going through the Anderson plug is much neater. That'll also give the inbuilt charge controller a chance to sort out the incoming power and send it to the cells before it goes out into the motor. If we hooked up directly to the pins of the motor, it would rob some of the power before it goes into the battery. So we're on top of the wheelhouse, or pilot house, sorry. Because our last job was to move the navigation lights up here. The main reason we've moved them is because we blocked the port light with a Minn Kota. The other thing is I'm not 100% convinced that in their old location these lights actually met the regulations. So the rules say that your port and starboard navigation lights have to be visible 22.5 degrees abaft the beam. I realise that the last part of that sentence might not have sounded like English to some of you. Let me just explain. The beam is just the widest part of the ship, but in seamanship terms we'll call that midships, or the middle of the ship. And abaft is just location relative to that, and that's so you know that we call port and starboard because, like, right now when you're looking at me, my right is your left and so on. But on a ship, port is always port and starboard is always starboard, so it's always clear where we're talking about. We have the same logic for fore and aft, so fore is just anything towards the bow, aft is just anything towards the stern, so we put all that together, and abaft the beam just means behind the centre line across the width of the boat. So these lights themselves are definitely compliant with the regulations. They've got an arc of 112.5 degrees, which is 90 from the centre line out to the beam, and then another 22.5 degrees. So the lights themselves are fine. The issue was with the location. They were mounted down on the bow, quite close to the centre line of the keel, and the problem with that is we've got a big wheelhouse in the way. So I'm pretty convinced that you wouldn't have been able to see these lights 22.5 degrees behind the beam. But where they are now, you definitely can. So we're happy. Now, I said in the last video that we'd take a closer look at this bit of handrail, and I totally forgot. So here we are. Now, we knew from the start, for this motor to deploy off the gunnel into the water, it was going to have to get past a bit of handrail. So we had to make a detachable section, and this is what we came up with. We were trying to think of an idea. We had two main priorities. It had to be strong, which this is, and it had to have as little visual impact as possible. We don't want to upset the aesthetic of a nice boat like this, or certainly any more than having a big motor on the front does. I think I gave a quick demonstration last time, but for a closer look here, we've got a pin on this end. You pull this pin, this end pops out. We'll then slide the rest of our removable section off of this part of the handrail. It's just a bit of solid steel bar. We went solid because it's a little bit stronger, there's a bit more weight to it. This side is actually held in with a grub screw rather than welded in. This end is welded in. There's no real getting around that. Now this is about as simple and as seamless as we could get this. There's no moving parts really apart from the pin. And by that I mean there's no springs and locks, things that can fail and give you problems. There's no sockets or big ugly connections anywhere. And that's what I mean by seamless. Obviously there is a seam here, but it doesn't really catch your eye unless you're looking closely at it. We've also got one bit of wire here that goes to our removable section, so we can't drop it in the sea. The other end of that connects to our pin, so we can't drop that in the sea either. And then to refit, we'll slide that on here. We need to feed this wire through. Pop that end back down and stick the pin in. That's it secure. It's actually quite strong and I think it looks pretty good. The only downside of using one piece of wire to connect the section of handrail and the pin and keep them both stuck to the boat is that this bit of wire here is a lot longer than it would have been had it just been for the pin, but I think we can live with that. With all of that done, we're hopefully at the last step, testing. So I've powered everything up, gone through the various electrical tests, I've paired the heading sensor and the remote. So let's fire it up and see how she runs. We'll start with the prop and I'll run it through the full speed range. As a success. That's good news, but this is the main reason I prefer a big dirty diesel to an electric motor. At least an engine will shudder and bang into life in some sort of dramatic fashion. That just worked. I mean, I'm happy, but it's a bit of an anticlimax. Anyway, let me check this rotates the full 360 degrees. Good, and the cable didn't snag, also good. Right, we're all good here. Now that I've got the wind in my hair, that means we're about done with this job. We're going to finish off other bits and pieces that this boat needs. I'm going to turn this off, that's just annoying. That was not worth that gag. This remote's pretty cool. Anyway, we're going to finish off other bits and pieces that this boat needs. Just simple things, basic service on the outboard, fitting a fuel pre-filter, changing the winch post and the trailer and so on. I've agreed with the owner that when we take this out to test and calibrate, I can bring you along with me. So hit subscribe, click the bell thing so you don't miss out on it. See you there. Thank you. Bye.